So now coming on to the part B of question 4, that is what is sampling from a distribution? Describe inverse transform sampling and Monte Carlo sampling with an example. So this question is very important because it connects probability, simulation and real world prediction. So what is sampling from a distribution? Sampling from a distribution means generating random values that follows the same statistical pattern as the original world data. In simple words, we do not copy old data. Instead, we generate new artificial data that behaves like real data. FIR crime example. Suppose in our 5000 FIR datasets, the victim's age is as follows: mean equal to 28 and standard deviation is 8, and the shape is approximately normal. So if we generate new ages like 27, 31, 35, 18, 29, these are not original values, but they are statistically resembles the real FIR data. So this process is called sampling from a distribution. Where is this sampling used? So it is used in simulation, bootstrapping, synthetic data generation, and Monte Carlo risk analysis. Now coming on to inverse transform sampling. So it is a method which is used to generate samples from any probability distribution using its CDF, that is cumulative distribution function. As long as we know the CDF, we can generate the new realistic values. So it consists of three normal steps, that is, first generate a random number u which is nearly equal to uniform 0 to 1. Second, apply inverse CDF, that is x equal to f inverse of u, and then the value of x becomes the final sampled value. So, inverse transform example from the FIR dataset. Suppose time since marriage has this CDF, which is mentioned in next page. This one. So now we generate a random number, that is u equal to 0.62. So, since 0.55 is less than 0.62 is less than 0.90, so it belongs to 3 to 7 category. So using this only, we can find and transform the sampling. So we will get time since marriage equals to between 3 to 7 years, most likely around 5 years. So this helps us generate realistic synthetic FIR cases. Now coming on to Monte Carlo sampling, so it means repeatedly generating thousands of random samples from known distributions to estimate uncertain outcomes and probabilities. Instead of using one fixed input, we simulate thousands of possible future scenarios. So when do we use Monte Carlo sampling? So we use it when the system is complex, mathematically uh, tough, or formulas are difficult and we want to simulate future uncertainty. Now, Monte Carlo example from the FIR dataset, that is scenario 1, is estimate the probability that a new FIR case will fall under BNS 80, that is dowry death. So from 50,000 FIRs, we estimate that dowry demand, if yes, then P equal to 0.32, injury type P equal to 0.12, since marriage is from CDF, and victim age is between normal 26,7. So gender will be 78% female. So relationship with accused from the training distribution. So step by step Monte Carlo simulation. So first step is sample dowry demand using Bernoulli, that is P equal to 0.32. Sample injury type using categorical distribution. Third, sample time since marriage using inverse transform sampling. Sample victim age using normal 26,7. Feed all the values into our IPC BNS prediction model. Then predict the legal section. Count how many times BNS 80 occurs. Final outcome. After 10,000 simulation, we estimate that the probability that a new FIR will be classified under BNS 80 under uncertain inputs. So instead of guessing, we get a data driven probability. Student example of Monte Carlo. Now for a weak student, we simulate 10,000 possible and end semester marks. Using inverse transform from a past weak student distribution, from this the scholar student may conclude that the student has only 18% chance of passing. Final concepts: sampling from a distribution generate a new realistic data that resembles the real data. Inverse transform sampling use inverse TDF to sample values, and Monte Carlo sampling run thousands of random simulations to estimate probabilities. Thank you.